चलो good evening everyone or phase 2 of DSIP IA, that is a project implement. This is a presentation for our phase 2 DSIP IA project implementation. We are from TYEXEP A2. Our group is group number is 25. I'm Nitik Agarwal and my partner is Preksha Bhandari. Uh, hmm. Our topic for the IA is face recognition using DSIP techniques. Face recognition is a biometric system that identifies individuals using facial features. We implemented this system based on selected research papers using DSIP techniques. We studied multiple papers and shortlisted four key research papers. Uh, Four of them would be eigen faces for recognition, eigen faces versus Fisher faces, face recognition using eigen faces, face recognition with local binary patterns. These papers guided our choice of PCA, LDA, LBP. PCA is mainly used in eigen faces, LDA is used in Fisher faces, and LBP is local binary pattern. These are the selected research papers, as I said before. This is the This is our system flow for face recognition. That is DSIP based, in which there is an image acquisition, that is the image getting captured by your local webcam or the dataset that you're choosing. Then there is image processing, in which you turn the image into a grayscale image, or you resize and filter it so it doesn't take much of your storage space. And then there are features extraction like PCA, LDA, LBP, DCT, FFT, etc. In the feature database, then this is stored in the database that we've created with the per person. For example, if we have two people, we'll make a different database for them and store their photos significantly so that the extraction can work on this database. And then the database is used to match the current webcam output, and then the face recognition output is shown based on the uh, database. Pre-processing techniques, images are converted into grayscale to reduce complexity. They are resized to a fixed size that would be 100 by 100 pixels depending on the code that we are writing. Then noise removal and normalizations are applied, and this improves recognition, accuracy, and stability. These steps are commonly used in all of the four research papers that we've chosen. Now we'll get on to the feature extraction PCA, which is used in eigenfaces. We studied this in the paper 1 and paper 3 out of the four papers. How PCA, that is principal component analysis, basically works. It converts images into numerical vectors, finds directions of maximum variance in the data, projects faces onto these directions called eigenfaces, keeps only the most important components. It is mainly used because it reduces data size, makes computation faster, extracts global facial features. The limitation of this would be that it's very sensitive to lighting and facial expression changes. The next feature is LDA, that we studied in uh, paper 2 and paper 3. LDA basically stands for linear discriminant analysis. It is used in Fisher faces. How it works is it uses class labels, that is person identities. For example, this picture is stored under this person, etc., etc. It maximizes the distance between different classes, minimizes variation within the same class. Applied after PCA to avoid mathematical issues. It is mainly used because it improves class separability, more robust than PCA under lighting variations, gives better recognition accuracy. Moving forward, now it will be continued by my partner Preksha.
LBP stands for local binary pattern. It is a texture-based feature extraction technique as studied from paper 4. It compares each pixel with its neighboring pixels, generating a binary pattern, which creates a histogram of a local texture. LBP is highly robust to illumination changes and works well for real-time face recognition. Classification. After feature extraction, we use classification techniques. We apply Euclidean distance, nearest neighbor classifier. The feature vector of the test image is compared with trained data, and the closest match determines the recognized person. Dataset. We created a custom dataset using a webcam. Standard datasets like ORL face database, Yale face database, and custom webcam database can also be used. All images were pre-processed before training to ensure consistency. Results. The system achieved an accuracy between 90 to 98% depending on the method used. PCA is fast but sensitive to lighting. LDA improves discrimination and accuracy. LVP is robust and suitable for real-time applications. Performance metrics. Performance metrics. We evaluated the system using accuracy, FAR, that is false acceptance rate, FRR, false rejection rate. These metrics measure the reliability and security of the recognition systems. Applications. Face recognition systems are widely used in attendance monitoring systems, mobile face unlock, security and surveillance, and biometric authentication. These are some examples. Conclusion. In conclusion, DSIP techniques like PCA, LDA, and LBP provide efficient and reliable face recognition. The system is computationally efficient and suitable for real-time implementation. The future scope for this is this system can be enhanced by integrating deep learning techniques, using larger data sets, and deploying in real-time security environments.
Moving on to the implementation of one of our topics from the four research papers, we implemented Fisher phase because it included PC and LDA both. So basically, how we started was we didn't use any database from Yale and all. We created our own data set by using the webcam of our laptop. We some First we took the pictures, pre-processed it, and stored it as a labeled data set. And we used to we took pictures of myself and Preksha and stored it in labeled data sets for person one or Nitik slash person two and Preksha. And then PCA is applied for dimensionality reduction, followed by LDA to extract Fisher face features. Then a KNN classifier is trained based on the dataset on the extracted features for face classification. In real time, which person is in front of the camera, that person's facial features is processed, and then the recognized person's name is displayed. Moving on to the next slide, I'll show you the implementation. Over here, as you can see, this is the PDA getting implied over here in the top left. I'm clicking pictures of myself with the person name being Nitik. I'm using space to capture and Q to quit. And this we are using PDA because it's the size is reduced and the picture is being clicked in grayscale so that it is easier to process it. And after this, we are clicking picture of my partner Preksha. Again, to train the dataset, to train the classifier properly, we would need at least 10 to 20 pictures per person in our dataset for it to be more accurate. And after clicking 10 to 20 pictures per person and saving it in the dataset, when I am in front of the camera, you can see it is showing recognized Nitik. And when I am putting my partner's picture in front of the camera, it is showing recognized Preksha. This was the implementation of our research papers and the Fisher face implementation with PDA. Thank you, and we'll end our presentation over here.